Here we are discussing the remainder and factor theorems, which stems from polynomials. Now, the remainder theorem is coming from when we divide a polynomial by another polynomial and when there is a remainder out of that division. So let's just use this example of dividing this polynomial by this other polynomial. We have to divide by the first term of the dividend, that's the polynomial to be divided. This is the divisor, the polynomial dividing. Okay, we divide the first term of the dividend by the first term of the divisor. So we have 2x squared divided by x, we have 2x remaining. Then we multiply everything in the divisor by that quotient, by the result of that division. We have 2x times x is 2x squared. 2x times plus 2 is plus 4x. So we are now going to subtract. Minus 5 minus 0, no constant term here. We have minus 5. And we have plus 3x minus plus 4x. That's like plus minus goes into to become minus. 3x minus 4x is giving us minus x. And 2x squared minus 2x squared is 0. So no need to write anything under there. Now we have this result. We divide the first term by the first term of the result. X divided into minus x is minus 1. 1 times x, minus 1 times x is minus x, and minus 1 times plus 2 is minus 2. We now subtract. Minus 5 minus minus 2, that is minus minus goes into to become plus. So minus 5 plus 2 is minus 3. Minus x plus x is 0. So we have minus 3 as remaining, because the first term here can no longer divide into this. They are not in same terms, and like there is no x there to divide. So this is the remainder. Now this is the dividend, this is the divisor, this is the quotient, the result of the division, and then this is the remainder. We usually write it this way. That the polynomial in terms of x is equal to the dividend, no, the divisor. I'm using divisor so as like b multiplied by the quotient plus the remainder. So you can as well go ahead and then write it that way. But that's not what we're here to discuss. We're here to discuss the remainder theorem. Now, looking at this divisor, let me have that here. Looking at this divisor, that is x plus 2. When we equate that into 0, we have that x is equal to negative 2. Now, let's substitute this negative 2 into the polynomial, the dividend. We are going to have that instead of having x squared, we're going to have minus 2 squared. We want to substitute this value into the polynomial, the dividend. Okay, plus 3 into negative 2 minus 5. We are going to have 2 into minus 2 squared is 4. 3 times minus 2 is minus 6 minus 5. 2 into 4 is 8, minus 6 minus 5 is minus 11. 8 minus 11 is equal to minus 3. Now take note of this, that when we divided this, we got this as the remainder. When we substituted negative 2, that's the opposite term of this divisor, of the constant in the divisor, we got the same answers as the remainder. So just keep that in mind. Now let's have this same given equation divided by another divisor, another polynomial divisor. So we have this. Let's go over it again. X divided into x squared, 2x squared is 2x. 2x times x is 2x squared. 2x times negative 4 is minus 8x. We subtract. We have minus 5. We bring that down. Then we have minus 8 is giving us plus 8. So plus 3 plus 8 is plus 11x. So this term minus itself is 0. We have x divided into plus 11x is equal to plus 11. And then plus 11 times x is plus 11x. Plus 11 times negative 4 is minus 44. We subtract. Minus 5 minus minus. So minus 5 plus 44 is 39. Okay, and then this term minus itself is 0. So this is what we have as the remainder. We keep that in mind. Now, like what we did previously, in the previous example, was to say something like x equal to, no, x minus 4, that's the divisor, x minus 4 equal to 0, therefore x is equal to 4. So this 4 is what we are going to substitute, the opposite sign of the constant term in the divisor. Okay, so when we substitute that into the given equation, we are going to have 2 into 4 squared plus 3 into 4 minus 5. This is going to give us 2 into 4 times 4 is 8. 2 into 8. 3 times 4 is 12 plus 12 minus 5. 2 times 8 is 16 and 12 minus 5 is 7. Oh, 4 squared is 16. Ah, that's what I was having. So 2 times 16 is 32. Sorry. So 32. 12 minus 5 is 7. 32 plus 7 is 39. So we have this. Now, we are going to say, sometimes you say that it's because it's same polynomial. Let's try with another polynomial to see whether we are going to be getting these same results from tweaking the divisor. Now, we have this polynomial to be divided. So, x divided into 2x raised to power 3, we have 2x raised to power 2 remaining. 2x squared times x is 2x raised to power 3. And 2x times plus 1 is plus 2x squared. We subtract. We bring down plus 4. We bring down negative 5x. 5x minus 2x is 3x squared. And then this minus itself is 0. So we are going to divide into this. X divide into, we are going to have plus 3x, and then 3x times x is 3x squared. 3x times 1 is plus 3x. We subtract. We bring down plus 4, and then we have minus 5 minus 3x is minus 8x. Now we are going to divide into this. X divided into minus 8x is negative 8. Minus 8 times x is minus 8x. Minus 8 times 1 is minus 8. We subtract. We have 4 plus 4 minus minus 8. That's plus 4 plus 8 is plus 12. And then this minus itself is 0. So this is the remainder we have. Now what do we do to check what we usually check? We are going to substitute. We are going to get this function as a function of the opposite sign of the divisor. So we have that function. We are going to have it this way. That function in terms of negative 1, that's the opposite sign of this, is equal to 2x, that's minus 1 raised to power 3, plus 5 into minus 1 raised to power 2, minus 5 into minus 1 is minus 1 plus 4. Minus 1 raised to power 3 is minus 1. So we have minus 2. Finally here, have minus 1 squared is 1. So we have plus 5. And then here, minus 5 times minus 1 is plus 5 plus 4. Then we are going to check for the answer. We have, if I start from behind here, we have 5 plus 4 is 9. 9 plus 5 is 14. 14 minus 2 is 12. We can see that. So we are already establishing something. But let's try one more time with this. So here we are having that this. So 2x into 2x raised to power 3 is x raised to power 2. X squared times 2x is 2x raised to power 3. And then minus x squared, we subtract. When we subtract, we are going to have plus 4 brought down, negative 5x brought down, and then plus 5 minus x squared. That is plus 5 plus x squared is plus 6x squared. This term minus itself is 0. We divide into this. So we are going to get plus 6x. 6x times, no, plus 3x, sorry, plus 3x. 3x times 2x is equal to 6x squared, and that's a positive value. 3x times minus 1 is minus 3x. We subtract. When we subtract, we bring down plus 4. Minus 5x, finally, plus 3x is minus 2x. When 2x goes into minus 2x, we're going to have minus 1. And then minus 1 times 2x is minus 2x. Minus 1 times minus 1 is plus 1. When we subtract, we are going to have 4 minus 1, which is 3. So 3 is the remainder here. Now for this one, we have this value here. We don't just have x minus 1, we have 2x minus 1. So we have that 2x minus 1 is equal to 0. That's to get what function of this we are to find, from which we are to find the remainder. We have 2x is equal to negative 1 goes over to be 1. And then when we divide both sides by 2, we have that x is equal to half. So this is the function of x we are going to solve for. So we have, when we solve for the function, like when we solve for half of that value, we have 2 half raised to power 3 plus 5 into half raised to power 2 minus 5 into half plus 4. Okay, we have 2 into 1 over 8, that is the cube of half. 5 into 1 over 4 minus 5 times half is 5 over 2 plus 4. Okay, and then we have 2 over 8 plus 5 over 4 plus 5 over 2 plus 4 equal to. Now the LCM of all this is 8. So we have 2. 4 into 8 is 2 times 5 equal to 10. 2 into 8 is 4. 4 times 5, that is 20. 4 over 1. Every whole number is over 1. So 8 times 4 is 32. Okay, so we add up. No, this is minus 5 over 2. So this is minus. So this is minus, not plus. We have 32 minus 20 is 12. So that 12 from here plus 10 is 22 plus 2 is 24. So all we have is 24 over 8. And we divide 24 by 8. That is 24 over 8 equal to 3. We can see that that tallies with the remainder from the division. So we've come to establish something. But before we go into conclusion, let's have this. Let's have this division so that we can conclude the remainder and factor theorem together. We have that x minus 1 divided into this polynomial function. We have x squared remaining here. X into x raised to power 3 is x squared. X squared times x is x raised to power 3. X squared times minus 1 is minus x squared. We subtract. Let me use another color for that. When we subtract, we are going to have plus 6 brought down, minus 5x brought down, and then minus 2 minus x squared is minus 2 plus x squared is minus x squared. This term minus itself is 0. We now divide into this. X divided into minus x squared is equal to minus x. Minus x times x is minus x squared. Minus x times minus 1 is plus x. We subtract. We are going to bring down plus 6. Minus 5 minus plus x, that is minus 5 minus x is minus 6x. This term minus itself is 0. So we divide into this. We have x divided into minus 6x is minus 6. Minus 6 times x is minus 6x. Minus 6 times minus 1 is plus 6. When we subtract, we are going to have plus 6 minus plus 6 is 0. Minus 6 minus itself is 0. So here we don't have any remainder. We don't have any remainder. And then to prove what we've been saying before, that when we have the function of, like let's have this function as we substitute the opposite sign of the divisor into that function, that is f of, this becomes plus 1, f of plus 1 is equal to x, that is 1, let me have another color for 1, that is 1 raised to power 3 minus 2 into 1 raised to power 2 minus 5 into 1 plus 6. What we will have is 1 raised to power 3 is equal to 1. 2 into 1 squared, that is minus 2. And then minus 5 plus 6. 1 minus 2 is minus 1. Minus 1 minus 5 is minus 6. And then minus 6 plus 6 is equal to 0. So we have come to that conclusion that when we have a divisor, that when we get the value of x, when we equate a divisor to 0 and then get the value of x out of it, when we substitute that value into the dividend, that's the original polynomial to be divided into, the result we'll get is the remainder from that division. So let's have it here, proof of remainder or factor theorem. Because from the remainder, we are going to have remainder theorem. But if it divides, just like this previous example we just had here, if it divides without having a remainder, that means that that divisor was actually a factor of that polynomial. That is, it can divide into it without remainder, is a factor. But when we have a remainder out of it, that means we are talking about remainder theorem. So to prove that the remainder theorem is actually true, we have a function in x is equal to, this is the divisor, this is the quotient, plus the remainder. Now, let's have that function in the remainder, that is opposite sign of the constant term in the remainder, is equal to, so x is going to be a minus that a, then q in the quotient in terms of a. Okay, a minus a is 0, so 0 times this function plus r, we are going to have 0 times anything is 0. Therefore, that function in a is equal to the remainder. So this is a stated fact. Now in the next video, we are going to be using this knowledge to solve some questions.